Hello everyone. Today we are going to deal with arithmetic and geometric series, and this is for our first quarter, week number 5, a first part of the most essential learning competency number 7, solves problems involving sequences. And my name is Flora May A. Lauta, and I will be your teacher for today. So today you are going to find the sum of the first n terms of a sequence. We are also going to determine the sum of a geometric series and solve for the sum to infinity of geometric series. And before we start, please prepare the following: your grade 10 module, your paper, and your ball pens. So the concepts and terms that we are going to tackle are arithmetic series, partial sum of arithmetic series, geometric series, sum to infinity, and take note that in mathematics, a series is the sum of the terms of a sequence. Arithmetic series is the sum of the terms of a arithmetic sequence. So to solve for arithmetic series, we follow two formula. We have S sub n is equal to n over 2 times 2a sub 1 plus the quantity of n minus 1 times d, or S sub n is equal to n over 2 times a sub 1 plus a sub n. Take note that n is the number of terms in the sequence, a sub 1 is the first term of the sequence, a sub n is the last term of the sequence, and d is the common difference. Okay, so let's have example number 1. Find the sum of the first 10 terms of the sequence 2, 5, 8, and 11. So here we are looking for the first 10 terms of the sequence, and then we are going to find the sum. So if you are going to list that will be 2 plus 5 plus 8 plus 11 plus until the 10th term, which is a sub 10, right? So to solve this, instead of adding it manually, we can use the formula here, which is S sub n is equal to n over 2 times, so that's 2a sub 1 plus n minus 1 times the common difference d. So let's find the given. We have our n, which is this one, 10. And then we have our a sub 1, which is the first term, this one. And the common difference, which is 3, because 2 plus 3 is 5, plus 3 is 8, plus 3 is 11. Or if you want to solve really the common difference, we have 5 minus 2, or a sub 2 minus a sub 1, which is the common difference. So that is 3. Okay, now let's solve. S sub 10 is equal to 10 divided by 2, and then 2, and a sub 1 is 2, plus our n is 10 minus 1, and then our d is 3. So 10 divided by 2 is 5, 2 times 2 is 4, plus 9 times 3. Okay, and then 5 times 4, 9 times 3 is 27, and then 5 times 4 plus 27, so we have 5. 4 plus 27 is 31, right? So this will be 155. Okay. So the sum of the first 10 terms of the sequence 2, 5, 8, 11, and so on is 155. Let's have another example. Find the partial sum of the first 20 terms of the arithmetic sequence if a sub 1 is 5 and a sub 20 is 62. So in this case, we are only given with the first term and the last term. So for that, we are going to use this formula. S sub n is equal to n over 2 times a sub 1 plus a sub n. Okay, and our n again is 20 divided by 2, and a sub 1 is 5 plus our a sub 20 is 62. So 20 divided by 2 is 10. 5 plus 62 is 67. So 67 times 10 is 670. And that is our sum of the first 20 terms. Okay. So geometric series is the sum of the terms of a geometric sequence. And we have different situations here. When r, or the common ratio, is not equal to 1, we use this formula. S sub n is equal to a sub 1 times 1 minus r to the power of n divided by 1 minus r, or S sub n is equal to a sub 1 minus a sub n, the last term, times the common ratio divided by 1 minus r. Again, this is applicable when our r is not equal to 1. Okay? Now, if our r is equal to 1, when r is equal to 1, S sub n is equal to the first term times the n. Okay, so how many terms we have? So take note that if you're going to use this formula when r is equal to 1, our denominator becomes 0, right? And then another situation is when r is not is equal to negative 1, and then our n is even. Remember, even numbers are 2, 4, 6, 8, and so on. Those are even numbers. So when r is negative 1 and your n is even, your answer will be 0. And then when r is negative 1 and your n is odd, meaning your n is 3 or 1, 3, 5, 7, 9, 8, and so on. Okay, the answer will be a sub 1. So I'm going to show you later some examples. So again, n is the number of terms, a sub 1 is the first term, and r is the common ratio. Okay, example number 1 for geometric series. Find the sum of the sequence 18, 54, 162, 486 to a sub 5. So as you can see here, it's just 5 numbers, right? So that will be S sub 5, or sum of 5 numbers. We can just try to do it manually first. So let us list the terms of the sequence, then add them. So that's 18 plus 54 plus 162 plus 486, and we know that the next term here will be 1458 since each term is multiplied by 3, right? So plus 1458. So if you are going to add them, the total should be 2178. Okay, now let's try to use the first formula. Say for example, we do not know the last term, a sub 5. So let's use the first formula. S sub 5 is equal to, or S sub n is equal to a sub 1 times 1 minus r to the power of n divided by 1 minus r. Okay, and then we have S sub 5, and a sub 1 is this one. This is our a sub 1, that is 18. 1 minus our r is 3, so that's 3, and then n is 5 divided by 1 minus 3. Okay, and then 18 times 1 minus 3 to the power of 5, that is 243 divided by 1 minus 3 is negative 2. So 18 divided by negative 2 is negative 9, And then 1 minus 243 is 242. So, negative 9 times negative 242, the answer is positive 2,178. And that is the sum of the first 5 terms of the sequence. So, as you can see, doing it manually and using the formula, we have the same answer. Or, since we know that a sub n is 1,458, we can use the second formula. S sub n is equal to a sub 1 minus a sub n times r is equal to 1 minus r. So that will be S sub 5 is equal to a sub 1. For example, here, that's 18 minus a sub n, which is 1,458, and then multiplied by our r, which is 3, divided by 1 minus 3. And then 18 minus 1,458 times 3, we have 4,374, divided by 1 minus 3, which is negative 2. So, negative 18 minus 4,374, the answer is negative 4,356 divided by negative 2. So, the final answer now is 2,178. Okay, so whichever formula you are using, you are still going to derive the same answer because of course they are all the same. Okay, only that again, this formula, this first formula here, you are only going to use it, or you can use it when a sub n is unknown. Or the second formula, you can use this when a sub n or the last term is known. And if there are only few numbers to add, you can just manually add them, right? Okay, so example number 2. Find the sum of the first 15 terms of the geometric series 4 plus 4 plus 4 plus 4 plus 4 and so on. Okay, so for this one, our sequence is 4, 4, and 4, and 4, and 4, and so on. And as you can see, our common ratio here is positive 1, since 4 divided by 4 is 1, or 4 times 1 is 4, 4 times 1 is 4, 4 times 1 is 4. So when r is equal to 1, we use this formula, S sub n is equal to n times the first term, a sub 1. Okay, so we need the first 15 terms, so S sub 15 is equal to, and n is 15, and our a sub 1 is 4. So that will be 15 times 4 is equal to 60. So therefore, the sum of 15 terms of this geometric series is 60. Okay? It's just like saying na meron kang 15 na 4. Diba? Kasi paulit-ulit lang naman yung 4 dyan. So, meron kang 15 na 4. Ibig sabihin, 15 times 4. Okay? Okay, so next example of geometric series. So, given the geometric series 3 minus 3 plus 3 minus 3 plus 3 plus and so on. So, kung ginawa natin itong geometric sequence, meron tayong 3, negative 3, and then 3, tapos negative 3, and 3, and so on. Right? So, first question, find the sum of the first 10 terms. So, we have first 10 terms, and then find the sum of the first 17 terms. So, for this, we know that, as you can see, our r is equal to negative 1, right? Because, again, when a sub 2 divided by a sub 1, that will be negative 3 divided by 3, which is negative 1. So, ganyan lang po. Don't forget. So, again, here, since our r is negative 1, we use this formula when r is negative 1. Only that, for this one, the S sub n is equal to 0, this is when our n is even. And then S sub n is equal to A sub 1, this is when n is odd. Okay, so let's try to solve this. Well, letter A, find the sum of the first 10 terms. So we know that our n here is 10, right? And 10 is it odd or even? Right, so it is even. So therefore, we are going to use this. So S sub 10 is equal to 0. So let's try to get a lower number so that we can just list this one to show you how we get 0. So for example, a lower even number. Let's try 4. So meron tayong 3 minus 3 plus 3 minus 3. So 3 minus 3, 0. Plus 3 minus 3, 0. Kaya naman, kapag even yung n mo, 0. Okay? So laging 0. Kasi lagi magpa-partner yung positive and negative, kaya magiging 0. And then, letter B naman, letter B, when n is 17, so 17 is an odd number, so the answer will be the first term, right? So, S sub 17, ang first term natin ay positive 3. So, that's it. That's the answer. But let's try a smaller number. Say, for example, 5. 5 is an odd number, right? So, that will be 3 minus 3 plus 3 minus 3 plus 3. Tama? So, 3 minus 3, that is 0. Plus 3 minus 3, 0 ulit. Tapos, may natirang isang butal, which is positive 3. So, 0 plus 0 plus 3, ang answer is positive 3. So, kahit ano pa yan, kahit anong number pa yan, basta odd siya, ang answer always is yung first term. A sub 1. Or this one. Okay? So, for example, naka-million ka, kailangan mo yung sum ng 1 million nito. 1 million. So, 1 million is an even number. Kung even, 0. So, kung 1 million 1, 1 million 1 is an odd number. So, ang answer is 3. Okay? Ganun lang po. Sobrang dali. Okay, so sum to infinity of geometric sequence and series. This is possible only when r is less than 1 but greater than negative 1. So we are going to use the formula S sub n is equal to A sub 1, the first term, divided by 1 minus r. And again, A sub 1 is first term and r is the common ratio. Let's have an example. What is the sum to infinity in the given geometric sequence 1/2, 1/4, 1/8, 1/16? Okay, so we are looking for what's this? The sum to infinity. Okay, so sum to infinity, we are going to use this formula again. Let's check first if our r is between positive 1 and negative 1. But it's obvious already because our given is fraction. So, r, what is r? R is 1/2. So, ma'am, paano naging 1/2? Okay, remember, when looking for or finding our common ratio, that is a sub 2 divided by a sub 1, and a sub 2 is 1/4 divided by 1/2. Okay, 1/2. So, what that will be 1/4. 1/4 times the how do you call this? The reciprocal of 1/2, which is 2 over 1. So that will be 2 over 4, and 2 over 4 is 1/2. Right? So that's it. Okay. Now let's solve for our sum to infinity. So, sum to infinity is equal to a sub 1. Our a sub 1 is 1/2 divided by 1 minus r. Our r is 1/2. So, 1/2 divided by 1 minus 1/2 is 1/2. So, 1/2 divided by 1/2 is 1. So, therefore, the sum to infinity of this given geometric sequence is positive 1. Okay. Okay, so we have here practice exercises. Find the sum to infinity of the following. 1/3, 1/9, 1/27. So to solve this, okay, let's find the r first. But it's already obvious that our common ratio is 1/3, right? Because 1/3 times 1/3 is 1/9, times 1/3 is 1/27. Okay, so let's solve for sum to infinity, which is a sub 1 over 1 minus r. And a sub 1 is 1/3. 1 minus r, 1/3. So we have 1/3 divided by 1 minus 1/3 is 2/3. So that will be 1/3 times the reciprocal of 2/3, which is 3/2. So cancel that out. We have now 1/2. So therefore, sum to infinity is equal to 1/2. Okay, now let's do number 2. So for number 2, we have 64, 16, 4, and 1. The common ratio is, so as you can see, we are dividing this by 4. So the answer is 1/4, right? So sum to infinity is a sub 1 over 1 minus r. So a sub 1 natin ay 64. Tapos 1 minus yung r natin is 1/4. So we have 64. And then 1 minus 1/4 is 3/4. Right? So 64 times the reciprocal of 3/4, which is 4/3. And that will be 64 times 4 is 256 divided by 3, or 85.33. Okay, so sum to infinity is 256/3. Alright, so another practice exercise: find the sum of the indicated terms of the following. So we have number 1, 4, 12, and 36, and then we need to find the sum of the first 7 terms, or S sub 7. Okay, so as you notice, 4, 12, 36, this one is geometric, and our R is equal to 3, right? So 4 times 3, 12 times 3, 36. So let's solve. Number 1 is with R equal to 3, and our formula S sub 7 is equal to a sub 1 times 1 minus r to the power of n divided by 1 minus r. So we are going to use this formula because, again, we cannot use this because we do not know our a sub n. If you want to use this, you have to find a sub 7 first. Okay, so let's just use the first formula. S sub 7 is equal to a sub 1. A sub 1 is 4 times 1 minus r is 3, and then our n is 7, and then 1 minus r is 3. So 4 times 1 minus 3 to the power of 7 is 2,187. And then 1 minus 3 is negative 2. So 4 divided by negative 2 is negative 2, times 1 minus 2,187 is negative 2,186 multiplied by 2. So the final answer is positive 4,372. Okay. Alright, now let's do number 2. So for number 2, 1, 4, 7, and 10, so we know that this is arithmetic sequence, right? And we need to find the sum of the first 10 terms. So for this one, since we do not know the a sub n, or the last term, we cannot use this, but we use this. Okay, this one. So that is S sub n is equal to n over 2 times 2a sub 1 plus n minus 1 times d. Okay, and our n is 10. So that's 10 divided by 2. 2 times a sub 1 is 1 plus n, which is 10 minus 1. And then d, our d is what? 1 plus 3 is equal to 4 plus 3 is 7 plus 3 is 10. Yan. Okay, ganun lang po. 10 divided by 2 is 5. And then 2 times 1 is 2 plus 9 minus 1 is 10 minus 1 is 9. And then our common difference, which is 3. So we have 5 times 2 plus 27. So 5 times 2 plus 27 is 29. So multiplied by 5 now. The final answer is 145. So that's it. Okay, another practice exercise. Find the sum of indicated terms of the following. So again, number 3, negative 1, 1, negative 1, 1. And then we're going to find the sum of the first 12 terms. So negative 1, 1, negative 1, and 1. We know that this is geometric and our common ratio is negative 1. So negative 1 times negative 1. Negative 1 times negative 1 is 1 times again negative 1. That's it. Okay, so let's go to this formula here. Ayan, so dalawa ulit. Looking for the 12 terms. So that's 12. And 12, which is our n, is 12, and 12 is even. So our answer for S12 is what? So when even, this is even, this is odd. So answer is 0. Right? Okay, now let's go to number 4. Sorry. 5, 5, 5, 5, 5. And we need to find the sum of the first 120 terms. So 5, 5, 5, 5. Our R is positive 1. So when R is positive 1, we do this. S sub n is equal to n, which is 120, times a sub 1, which is 5. So S sub, what's that? 120 is equal to 120 times 5. And the answer is 600. Right? So the sum of 120 numbers in the sequence is 600. Okay, so that ends our lesson for today. And just to recap, we were able to talk about arithmetic series, which is the sum of the terms of an arithmetic sequence. The partial sum is the sum of a limited, that is to say, a finite number of terms, like the first 10 terms or the 5th through the 100th terms. And a geometric series is the sum of the terms of a geometric sequence. And before I let you go, I just want to leave you this message. Be brave. Always remember, you are braver than you believe, stronger than you seem, and smarter than you think. And thank you so much for attending. Please don't forget to like, subscribe, and comment below. Thank you. Bye.